here is telling you that the sample size or sample space is 11. The probability of success is 15% of 0.15, and you are accumulating area to the right of 4. By the way, sample size is 11, so let me just list the kind of probabilities we can have. We're going to find P0, P1, P2, P3, P3, P4, P5, P6, up to P11, because this is binomial distribution. So what actually is P0? Remember, if you're told to find only P0, it means you put in 0 as the number you want at a time. So remember, the binomial formula is n combination r, success to power r, and failure to power n minus r. And so what you're going to do is put in the what you know. I know that n is 11. I know that this particular question here says less than or equal to 4. So it means that I'm accumulating from 4. So I'm going to accumulate from P4 down because this is less than. I'll be accumulating from P4 down. I just want to remind us that P0 means 11 combination 0, success to power 0, and failure to power 11 minus 0. 11 minus 0. Okay, but I'm not doing it one by one because it's going to take me all the time. I actually want to do it together. I'm going to use binomial cumulative density function. So I will accumulate it from 0 to 4 altogether. If I'm told to make a table, then I can do it one by one. But I'm not actually making a table of binomial distribution. I'm just trying to find the area under the binomial distribution starting from 4 to 0 using all the things given to me. I'm given that sample size is 11. I am given that success is 15%. So what we're going to do now is bring a calculator and then turn my calculator on. But what is the argument? Remember that the argument is binomial cumulative density function. This is not the normal distribution. This is binomial. Binomial cumulative density function. This is what I'm going to tell my calculator. I'm looking for area to the left, starting from 4, where 4 is included. So the argument is n, comma, success, comma, x, random variable, or r, where n is the sample space, p is the success given to us, and x is the random variable. All right, so I will now put it in the way I am. So I'm going to put it in binomial. I'm going to draw a line from here. So binomial CDF, cumulative density function. The sample size is 11. Success is 15% of 0.15. You can't write it in percent. Success must be in decimal, 0.15. I'm accumulating from 4, where 4 is inclusive, because it says less than or equal to 4. So I'm going to write 4 there. And then I will use binomial CDF. So I'm going to tell my calculator what to do. So I'm going to go to second distribution. I'm looking for binomial. So binomial cumulative density function is B. So I'll select B. And the number of trials is asking me what is the sample size. Anytime you're told to find the number of trials, it means what is the sample space. And sample space is 11. P is asking me, P is the probability of success given to you, and it must be in decimal, 0.15. And X is the random variable. Where are you starting? Is that X is 4 included? Yes. Why is 4 included? Because the question says starting from less than or equal to, so that is 4. And then I'm going to select paste and calculate. When I hit enter, it tells me that area under the curve is 0.984 to 3 decimal places. Therefore, if I cumulate binomial cumulative density function of 0 plus 1 plus 2 plus 3 plus 4, I'll get 0.984. So that answer is 0.984. 0.984 area to the left. Even if you put it on a table and do it one by one, you will still get the answer, 0.984. And what if you are told to find the mean? What is the expectation? Anytime you're told to find the expectation in binomial distribution, it is the mean. So what you want to do is you can just say NP. N, the sample space, multiplied by success. So expectation, the mean, let me just write mu. The mean is equal to what do we know as N is sample space. That's 11 multiplied by 0.15. So the sample space is 11 multiplied the probability of success. So I'm going to get my calculator and clear and find the mean. This time it's the ordinary mean, it's not mu x bar. So the mean is sample space multiplied by the probability of success, and the probability of success is 0.15. And when I hit enter, the mean is 1.65. When I hit enter, the mean is 1.65. Okay, so what if in this probability distribution, what if I'm told to find area between? I could be told to find area between in binomial distribution. I could be told to find area between. Okay, so what if I am told to find area between in this binomial distribution? I think I'm going to take this to my whiteboard. Okay, I am taking that question to my whiteboard so that I can find area between at least. So we have already done at least binomial distribution. We're going to do between in binomial distribution. And okay, I mean, we're done at most. So the next one now is write what I'm given. I'm given a binomial distribution whereby n is equal to 11. Probability of success is 0.15. So the first question we answered is find the probability of the random variable x is less than or equal to 4. The sample space is 11, so I can be told to find B. Let's find B. Suppose I'm told to find the probability such that 4 is less than or equal to the random variable x, and x is less than or equal to, I'm going to put 8 here or 9. 9. Note that I have less than or equal to on both sides. Therefore, the extremes are included. Okay, and this is between. In binomial, I can also have at least. So I can be told to find the probability that random variable x is greater than, and I think we just did that, but let me, is greater than or equal to 4. If it's greater than or equal to 4, it starts from 4 to 11. Okay. And okay, now we can be told to find the probability of p, the random variable, is equal to 4 exactly. So this question is an exactly question. Whenever you see equal sign is an exactly question. Exactly question. So this is about review of binomial distribution. Anytime you're told to find the probability of greater than or equal to, this is called an at least question. At least. In binomial, that's what is called at least question. And this is a between question, between question in binomial. And this one right here is at most question, less than or equal to. This is at most question. Okay, so we have already answered the at most question. So the next thing we want to answer is at least question. So I'm going to, between question. So let's, on the same diagram, we want to, let me draw a normal, well, a curve there, something like, looks like a normal curve. Okay. 4 from 4, which is P4, this is P4, to P9, this is P9. And I am going to find area, make it area between, so I'm going to find, in other words, I'm looking for P4 plus P5 plus P6 plus P7 plus P8 plus P9. I can do them individually, or I can do them with my calculator, accumulating and subtracting. If I'm looking for exactly P4, it means I can accumulate from P3 down. So if I accumulate from P9, and then I'll subtract it from P3. So this is what I'm going to tell my calculator now. So I am going to tell my calculator, find the binomial cumulative density function starting from 11, 0.15, and then random variable is 9 minus binomial CDF starting from CDF starting from 11, the same probability of success. I am subtracting, so I will just subtract a number lower than the next digit below 4, because if I subtract 4, I change the question. So I'm going to subtract 3. So subtract the random variable 3. So I will get my calculator and do that. Do just that. And I'll get my answer using, so now I'll get, so this is binomial between. This is not normal distribution. You could be told to find binomial between, and you can use your calculator. So be careful what the numbers that are included. So in this between, B, 4 and 9 are included. Imagine the compound inequality says just 4 is less than x and x is less than 9. then the inequality does not include the extremes. But right now, the inequality includes the extremes. So you have to be careful how you tell your calculator what to calculate. So now I'm going to tell my calculator that I'm going to binomial cumulative density function. Okay, so second distribution, and I will arrow to binomial PDF, binomial CDF, sorry. Select binomial CDF, and the argument is still the number of trials is 11. Success is the same, and the value this time is starting from 9. Okay, and I am going to paste, and maybe I don't have to paste it. I can just subtract. I will just put subtract, and I'll go back to second distribution, go back to binomial, CDF, and then the same sample size, the same success. This time I'm subtracting 3 because 4 is included. I'm subtracting 3 because 4 is included. All right, so if I hit enter, I have calculated the probability for P4 plus P5 plus P6 plus P7 plus P8 plus P9. I use my calculator to calculate them. And therefore, my answer is to 3 decimal places 0.069. So that probability is 0.069. 0.069. So the probability is 0.069. So 0.069. So that is how to calculate the probability for between in binomial distribution. So be careful. The compound inequality tells you where to start and where to stop. Okay, so now I am going to see the question in C, the binomial in C says I need to calculate an at least question, and that at least starts from 4. If it's an at least question and it starts from 4, so 4 is included. All right, so if it starts from 4, it means I have to, let me clear, I'm going to draw actually some kind of area, and then I will show the area I'm supposed to find. Okay, so by the way, if it says, by the way, the sample size is 11, and I am told to accumulate from 4 to 11. In other words, I'm looking for the PDF of 4 to PDF of 11, inclusive, from 4 to 11, all of them. Okay, and I can do that using my calculator. So this is the argument. Because I am accumulating from 4 to 11, I will do complement. 1 minus binomial CDF, anytime binomial CDF, anytime I am told to do an at least question in binomial, then I must do binomial CDF, an at least question. So sample size is 11. Success is 0.115. And what is the number that should be the random variable? It better be 3, because I cannot subtract 4. 4 is included. So I have to subtract a number lower than the integer, lower than 4. So that's why I'm doing complement. Now I will get my calculator and tell my calculator what I want to do. So I have 1 minus, and by the way, the total probability has to be 1 because binomial distribution has to obey the laws of probability. The laws of probability says that the sum of all the probabilities must be 1. Therefore, the binomial distribution must be all the probabilities. So 1 minus binomial CDF. So I'll go to get that. So this is an at least question in binomial distribution. In at least question, you do complement rule. And then, why 3 should be here? Because 4 is included in the question. I cannot subtract 4. All right, so I will paste. Then I will get an answer. I want you to know that I'm doing 1 minus. So I just found the area from 4 to 11. I found the area from 4 to 11. So 0.069. So the area is 0.069. Area from 4 to 11 is 0.069. The area from 4 to 11 is 0.069. Okay. Now we just finished with an at least question. An at least question in binomial distribution, you can use complement. That's what we just did. You can use complement that we just did now. We already did between question, and we also did at most question, which is less than or equal to. Let's do an exactly question. Exactly means is. So exactly is the same thing as is. All right, so I will now tell my calculator to find the probability of the random variable is equal to 4. So P4, that's all I'm doing. And that is the same thing as 11 combination 4, success, and success is 0.515, success to power 4, failure. If success is 0.15, failure is 0.85. So 0.85 to power. So 11 minus 4, if I subtract 4 from 11, I have 7. Okay. Okay, so that's actually what I'm evaluating. Okay, so another way I can do it is just get into my calculator. Let me get into my calculator. I'm gonna hide this. And then I will just grab this and move it up. Okay. Now I want to calculate binomial PDF. This is probability density function because I'm doing an exactly question. Anytime you're given an exactly question in binomial distribution, then you must do binomial PDF. Okay, so binomial PDF of sample space is 11, success is 0.15, and I am already doing PDF of 4 only, simple probability distribution, a single probability. So I'll get my calculator and I show my calculator where PDF is. So second distribution, and I am looking for binomial PDF. Note that this is PDF, so I am going to select a single probability. What is the number of trials? In other words, what is the sample space? The sample space is 11. What is the probability of success? It's 0.15. What is the random variable? The random variable is 4. Hope you know it cannot be a decimal. Random variable is not allowed to be decimal. So I am going to hit enter. And so the probability of exactly 4 is 0.054, approximately 0.054, 0.054, approximately. So the probability of exactly 4 is 0.054. So this is a review of binomial distribution, where I am given exactly. So I'm given exactly, at most, and at most is less than or equal to, at least is greater than or equal to, between is just between. So you have to look at the compound inequality to make sure you know what you are doing. So this is review day 1. We have another review day on Wednesday, and then another review day on Friday. Okay, so I am going to stop this video so it will not be too long.